Samsung's latest semiconductor production line reduces the surface area of its chips by 16%, reduces power consumption by 4 to 5%, and improves performance by an impressive 23%. This video tells you everything you should know about Samsung's 3nm gate-all-around chip production design. On June 30th, Samsung announced it had taken a crucial step toward rolling out its 3nm Gaafet technology, which stands for 3nm gate-all-around field effect transistors. You may also refer to it as 3GAE, meaning 3nm class gate-all-around early. It is a trailblazing manufacturing technology that has the potential to revolutionize the semiconductor industry. And this video tells you everything you should know about it. The news is significant because it makes Samsung the first company in the industry to commercialize a 3nm class manufacturing technology, bringing a development process that lasted several years to a successful end.
Congratulations, General.
In the brief announcement, Samsung indicated that the production line employs the company's signature 3GAE technology, which is based on gate-all-around (GAA) transistor architecture, a modern transistor design. Later in the video, we'll explain what GAA is and how it relates to Samsung's 3GAE. The announcement came amid a drop in global chip production, a situation that poses a business threat to manufacturers of electronic gadgets which need the most advanced chips. Samsung will manufacture these high-level 3nm chips at its Hwaseong and Pyeongtaek chip plants. Moreover, the company expects the new manufacturing technology to improve chip performance, reduce power consumption, and boost transistor density. However, 3GAE might not appear on the market soon, since Samsung must fine-tune the technology. Chip manufacturers take great pride in reducing the size of their processors because it is an expensive and tasking process. However, these manufacturers strive to innovate consistently since chips with a smaller number of nanometers are more advanced and power efficient because they improve transistor density, which then improves efficiency. Since 2000, companies like Samsung, IBM, and Global Foundries have worked on the transistor design known as gate-all-around (GAA). In traditional transistor designs, the gate material surrounds the silicon semiconductor channel on 3 sides, as used in current FET devices. However, in GAA, the gate material surrounds the silicon semiconductor channel on 4 sides instead of 3. Hence, GAA reduces design size and increases the potential for scaling the channel length, 2 factors that contribute to increased transistor density. Furthermore, gate-all-around (GAA) structures can be built using nanowires or nanosheets. Whereas nanowires are difficult to create but ideal for low-power applications, nanosheets, which Samsung will use for its 3nm node, are thought to provide advantages in performance and scaling. Samsung refers to its nanosheets as MBC-FET, which stands for Multi-Bridge Channel Field Effect Transistor. Samsung had been working on MBC-FET long before it announced it in 2019. The width of the nanosheet is a key metric in defining the power and performance characteristics of nanosheet-based field effect transistors, FETs. The wider the nanosheet, the higher the performance at higher power. As a result, transistor designs focusing on low power can employ smaller nanosheets, whereas logic requiring higher performance can employ wider sheets. Samsung has already begun producing the first generation of 3nm chips, and it expects the production technology to make the new 3nm chips more efficient than the 5nm chips on the market. Compared to 5nm chips, Samsung expects the latest production line to reduce the surface area of first-generation 3nm chips by 16%, reduce power consumption by 4 to 5%, and improve performance by an impressive 23%.
Yeah, isn't that something you've always wanted?
The South Korean powerhouse also maintains that second-generation 3nm chips will consume half of the power currently used by 5nm chips. According to a company spokesperson, production of the second-generation 3nm process will commence in 2023. Furthermore, the company intends to use the 3GAE technology to manufacture chips it labels high-performance, low-power computing. It hopes to produce processors for mobile devices subsequently. Subscribe to this channel for your timely and authentic Samsung updates. Samsung has been competing with TSMC in recent years. The Taiwanese chipmaker signaled in June that it also plans to commission bulk production of a 3nm chip process in the second half of 2022 and produce 2nm chips by 2025. With its 3nm process technology launch and the construction of a factory we'll soon tell you about, Samsung is attempting to catch up to its bitter rival TSMC, which has decisively seized the lead in the 5nm or 4nm generation. The difference between TSMC and Samsung has widened to the point where major clients like Qualcomm turn to TSMC to produce high-performance chips like the Snapdragon 8 series. Because Samsung has had relatively little success with 5nm or 4nm chips compared to TSMC, having the first fab with Gaafet technology could give Samsung a temporary but significant advantage over TSMC, whose 3nm process still uses older fin FET-style transistors. Dr. Siyong Choi, president and head of foundry business at Samsung Electronics, said, "Samsung has grown rapidly as we continue to demonstrate leadership in applying next-generation technologies to manufacturing, such as foundry industries' first high-K metal gate, FinFET, as well as EUV. We seek to continue this leadership with the world's first 3nm process with the MBCFET." Samsung revealed in 2021 that it would invest $132 billion in the logic chip and foundry industries by 2030. Additionally, Samsung Electronics plans to soon establish a $17 billion semiconductor factory in Texas. Poised to compete, TSMC also announced in April 2022 that it would spend $100 billion over the following 3 years to increase its chip fabrication capacity. Now that you've learned about Samsung's 3GAE chip production technology, why don't you take a trip with us into Samsung's Digital City, the first $300 million digital tech city?